LDAR in just a few slides. I'm John Wigger with Cadenza Environmental. Been doing this for a long time. We'll get you right to it. Again, my name's John Wigger. I'm with Cadenza Environmental out of the Chicagoland area. This is really just an introduction to what leak detection and repair is. This is not meant for people that thoroughly already know what it is. This is for people who have heard about it and wondered, what is LDAR? We're going to answer that real quickly. So first of all, purposes of an LDAR program is to find and repair leaks from process equipment. The basics of air pollution rules I'll present here. Equipment that needs to be monitored, the methods of which it's monitored, instruments, sensory, the record-keeping requirements, and then the reporting requirements. So this all began with air pollution regulations all the way back from 1963 with multiple amendments in 1970, 1977, and then very comprehensive changes in 1990. The rules introduced were to improve the air quality around the U.S. U.S. EPA determined that leaks from petrochemical and refining industries, as well as others, were contributing significant levels of volatile organic chemicals to the atmosphere through leaks of process equipment. Among many new regulations developed, LDAR rules were designed to address and reduce atmospheric emissions from equipment leaks, often referred to as fugitive emissions, and you may have heard that before. So the basics of the rule. Well, the rules address the applicable facilities, petrochemical plants, refineries, oil and gas industry, and others. Also hazardous waste facilities that are treating hazardous waste, for example. The rules also address leak definitions. I mean, what is a leak? Is it one molecule of VOCs? Is it a concentration? I'll get into it, but it defines what a leak actually is. Then the monitoring requirements. How are you supposed to know and find, and what are you supposed to do to find these and then correct them? The equipment that needs to be used to be able to find and correct these problems. Also some of the human sensory guides that you can use to find and repair leaks. Then also, again, the repair requirements and the timing of and frequencies of having to monitor and look for leaks, and then the record keeping and reporting requirements associated with this and the rules. So, equipment monitoring. Leaks occur. Leaks occur in all kinds of process equipment. Leaks occur in flanges and connectors, in valves and valve stems, the ends of pipes, in pressure relief devices. They happen. On the screen here, leaks can happen around the stems. They can happen in the seals between pipes, all kinds of places. How do you find these leaks? So methods for finding these leaks. There's instrumentation involved, otherwise known, some people, you'll hear the term method 21. All it does is refer to a specific kinds of instrumentation that's used to help find it. As pictured on the screen, it references a regulatory citation of the equipment that's used. That's why it's called method 21. In this case, it's a handheld, quote, sniffing instrument that provides a reading that can indicate whether a leak of volatile organics is occurring. And these leak definitions can vary by what the concentrations are and what the readings of this sniffing is. It's required on all of these pieces of equipment that I referred to earlier. It also specifies how you thoroughly monitor each piece of equipment. You know, you got to go around the whole piece of equipment. It can take anywhere from a minute or so on each component, or maybe only a few seconds to a few minutes if it's a large piece of equipment, and many different places that it could leak. You're required to go and look at each one of those and sniff all around those areas. This instrument also records the levels at which it's measured. There's other ways of finding leaks as well. Audio-visual olfactory, you may hear people refer to AVO leaks. Basically, that's using human sensory methods of hearing and seeing and smelling leaks. It can also be a valid way to determine if a leak is occurring in some pieces of equipment, and it's required in some pieces of equipment, such as finding drips in a pump seal, dripping liquid, or hearing a high pressure release from a valve or from a pipe. They can also be valid ways, again, of hearing or indicating whether a leak is occurring. So the other thing the rules specify too is how and when do you have to do this? How I just addressed. How often? Well, it varies. Sometimes it's weekly on certain pieces of equipment, pumps, compressors, etc. Just by visually inspecting whether or not any leaks may be occurring, liquid dripping from the seals, that kind of thing. Monthly on valves, or if you have a history and can show that they don't leak very often, and there's ways to determine that, then you can move to quarterly or even longer periods of time to actually go around sniffing these valves. And remember, we're talking about refineries, petrochemical facilities. This can be thousands, if not hundreds of thousands of components in a refinery that this has to happen. This can take, and does take, teams of technicians that spend their entire time, weeks on end, going around and doing these monitoring and inspections, let alone the repairs that may occur by finding a leak. So that's why these LDAR programs can be significant and quite costly for the industry. So what happens if you find a leak? Well, if you find a leak, the rules require that you repair these leaks. Typically, at least you have to give an initial attempt within the first 5 days of finding the leak. And usually, or in most cases, you've got about 15 days to actually find and have some kind of final repair on it. The first attempts can be as simple as tightening some bolts, replacing some bonnet bolts, tightening some things, working a valve to see if that can help stop a leak from actually occurring. Final repairs can be things like drilling into a valve and replacing or lubricating the packing, doing a thing called drill and tap, where you actually put new packing in a valve that's in line. You don't have to take it out. Other ways, you can actually isolate the valve, pull it out and replace the valve. So all of those things need to be typically done within 15 days or so. There's differing rules and differing ways that has to be done. I'm not getting into all of those specifics. There are some provisions where it's just maybe either physically impossible or too dangerous, or takes too much time to be able to actually fix something within 15 days. And in those cases, there are some provisions where you can allow something to continue to leak until the next time it's safe to be able to repair that. And that's called the delay of repair program. Not used all that often, but it does need to be done. Sometimes in order to repair something, you can actually create more emissions from shutting a process unit down than you would otherwise if you are trying to repair some small leak. So that's why these delay of repair provisions are in place. So you have to repair, find, monitor, repair. You also have record keeping requirements for all of this. And usually, as I had referred to earlier, these are massive amounts of information, and there are actually commercially available databases that are available for people to be able to use. So you can maintain, with record keeping, you have to maintain a list of all of the different components that are subject to these leak regulations. You have to keep track of when you monitored, how often you monitored, and the monitoring results from that. You have to maintain detailed schematics of the equipment, the design specifications for all of this. You have to maintain results of the performance testing that I just referred to, and the leak detection monitoring that you do on a weekly, quarterly, semi-annual basis. If you do find components that are leaking, then under most rules, you have to attach literally in the field ID tags on those pieces of equipment to identify that they that are leaking. You have to maintain records of the components that are leaking, the instrument and the operator ID that did it, the date, the time that the leak was found. You have to maintain a list of the dates of the repairs or the attempts of repairs for each one of these situations. You have to note the dates of successful repairs, and you have to note and keep track of and include the results of the monitoring test to determine if the repair was successful or not. So again, you have to keep track of all of this, and there are massive commercially available databases. You can use other ways of doing it as well to determine whether or not you have satisfied all that. Lastly, there are reporting requirements that the rules require too. There are initial startup reports of any new components and new process units that start up. Then you have to report the numbers of valves, pumps, compressors, connectors, the different components that are being monitored. You have to report that. On semi-annual reports, you have to report any new process units and the number of leaks that were found in the valves, the pumps, all the different equipment, as well as the numbers of leaks and information about things that were not repaired on time, things that are put on delay of repair, or if they were not reported and or repaired according to the regulations. Essentially, you have to report on the fact that you may not have met the regulations. You have to report that. The dates of new process unit shutdown and the revisions of past reports and changes in the numbers of these things on a semi-annual basis. That's it. That is LDAR in a nutshell in a few slides. I hope you found this was useful. So if somebody ever asks you what is LDAR, at least you have a little bit better idea of it. Thanks for your time.